Hello everyone. Today in this module we are going to talk about conservation management strategy. This module is a part of conservation ecology. We know that the management of natural resources is a complex process as it is driven by the dynamics of natural system and lot of uncertainty at different levels of management. So, in order to conserve nature, in this module we are going to learn about the adaptive conservation strategies which are employed. The learning objectives of this module are a general introduction to the conservation management strategy, adaptive conservation strategies, management strategy evaluation, examples of conservation strategy and limitations of management strategy evaluation. As habitats and ecosystems become increasingly altered and populations ever more impacted by anthropogenic activities, a growing number of species will require some form of management of both individuals and populations to ensure their survival. Effective species conservation planning should consider all options when assessing what actions are necessary to address the conservation pressures facing a particular species. Ex situ management has been used to deliver conservation benefit for threatened species. Species extinctions have been prevented, and for an increasing number of species there have been conservation restorations or introductions following periods of ex situ management. The management of an ex situ program is a cyclic process of implementation, monitoring, feedback and adjustment of both biological and non-biological aspects until either the goals are met. In addition, as conservation challenges become more complex and urgent, the need to further develop scientifically based and innovative approaches of ex situ conservation will increase. A conservation management system, that is CMS, is a procedure for maintaining a species or habitat in a particular state. It is a means of wildlife is secured in a favorable condition for contemplation, education or research in perpetuity. It is an important topic in cultural ecology where conservation management counterbalances the unchecked exploitation management of natural resources. Conservation management system or CMS are vital for the turning sustainable development strategies into successful operations. Adaptive conservation strategy. An adaptive conservation strategy is a two-pronged approach that can help both conservation scientists and resource managers achieve their goals. It fosters applied science through true adaptive management on the ground and fosters learning organizations through the development of adaptive conservation plans. An adaptive conservation strategy consists of adaptive management at the site-specific level and, in addition, adaptive conservation plans that provide a systematic means of synthesizing data, sharing learning, and influencing policy across sites and ecosystems. In other words, an adaptive conservation strategy recognizes that we all learn best by doing and by learning from the experience of the others. An adaptive conservation strategy includes adaptive management at the site-specific level combined with the process of adaptive conservation planning across sites to more fully integrate scientific knowledge into resource management and share learning among conservation practitioners. Adaptive management is a decade-old method of natural resource management that integrates design, management and monitoring of systematically test assumptions in order to adapt and learn. Adaptive conservation planning is the process of synthesizing, monitoring and assessment data from many projects to develop science-based conservation recommendations that can then be shared across the projects. Adaptive conservation strategy is equal to adaptive management plus adaptive conservation plans for sharing and learning. An adaptive conservation strategy emphasizes science management teams practicing adaptive management. This approach means resource managers and scientists work together closely to identify important resource management questions and monitoring regimes that are most likely to provide answers. Teams conduct standard monitoring of bird species and associated habitat features to evaluate conservation practices, results and goals at multiple sites. The steps of implementing an adaptive conservation strategy are: first is the use adaptive management, stressing science management teams at multiple sites within an ecosystem or with similar natural resources across ecosystems. For example, riparian habitat, identify assumptions and set management goals, implement management actions, monitor and analyze response to management, and the last is revise management goals or monitoring regime as indicated and repeat the process. The second step of implementing an adaptive conservation strategy are to share learning through adaptive conservation plans. It includes synthesize findings from multiple adaptively managed projects, then to develop an adaptive conservation plan focused on the species, habitat or ecosystem of interest. The plan incorporates findings from step 1 as well as peer review literature, grade literature and expert opinion. Conservation plans advance recommendations to guide resource management and policy and are available online as well as in hard copy. Next, to disseminate and incorporate plan recommendations into resource management and policy by partnering with or conducting outreach of appropriate audience. Next, reassess and revise both site-specific resource management plans or practices and adaptive conservation plans and repeat the process. In this figure, we can see the components and process of an adaptive conservation strategy. An adaptive conservation strategy can also be applied as a means of evaluating the success of conservation effort in biological terms. Adaptive conservation planning produces undatable web-based conservation plans and basis for wide dissemination. The crucial components of a successful adaptive conservation strategy are collaboration, teamwork at the project level, keeping data current, information sharing, effective communication, flexibility from all sides including funders, and a result-oriented applied focus in monitoring, research and management. The most fundamental point is that both conservation scientists and natural resource managers serve the same mission, that is facilitating and advancing successful, cost-effective conservation of the world's precious natural heritage. An adaptive conservation strategy provides a win-win approach for achieving this mission. Management strategy evaluation. In complex systems with multiple stakeholders and severe uncertainties, it is generally difficult to provide a single best harvest policy. Instead, there is a need to find robust approaches that meet management objectives under a range of potential states of the world. One approach that aims to do this has gained considerable ground within fisheries sciences. Management strategy evaluation, that is MSE. MSE uses simulation modules within an adaptive framework that enables the comparison of alternative strategies in a virtual world under multiple and often conflicting objectives. MSE, in common with adaptive management more generally, has 4 major advantages over standard approaches to providing management advice. First, it allows experimentation with a range of possible management procedures under a range of circumstances. Secondly, stakeholders can be directly involved in the development of the management scenarios and the evaluation of the metrics by which the performance of different management options is assessed. Third, MSc enables researchers and managers to examine the implication of various forms of uncertainty, including process, measurement and structural uncertainty on the performance of different management options. And fourth, MSc carries out prospective rather than retrospective evaluations of the performances of different management procedures under a range of circumstances. By comparing the performance of a range of alternative strategies under possible scenarios upfront, the response of the system can be compared with the desired goals and evaluated in advance in implementation. MSc enables fisheries scientists to give resource managers advice on robust management procedures as well as on trade-offs involvement with each procedure. The learning process can be incorporated into number first, the assessment component of the management procedure when new observations become available, and second, the decision process based on a review of the performance of the management strategy. Together with the modeling tools such as sensitivity analysis, MSCs can evaluate which data and how much of it should be collected and how often monitoring should be carried out to improve management performances. Stakeholders can be involved at various points of the process of proposing and evaluating different HCRs and assessment approaches. There is ample evidences from terrestrial conservation and fisheries that stakeholders' involvement throughout the process of resource management is key to compromise between stakeholders, acceptance of the rules and hence the sustainability of resource use. Future directions for the management of natural resources including the wider ecosystem. Most applications of the MSc approach have focused on harvest strategies for target species. The direct effects of harvesting on the ecosystem are rarely incorporated into MSc. However, it is changing in fishery sciences increasingly takes an ecosystem approach. For example, Atlantis model for southeastern Australia, multi-species population models and effects on the wider ecosystem have recently been included in an MSc for a prawn fishery in Australia. Similarly, MSCs are now being used to evaluate strategies for limiting bycatch including cetaceans. More realistic economic based management has been demonstrated to be better in terms of sustainability of the stock and the profitability of fishing. Examples of conservation strategy. A global research and conservation strategy has been developed and is applied in 4 stages at each of the sites. Stage 1, assessing ecosystem diversity and function. The first stage at a new site is to determine the relative biodiversity value of the site to determine the protection requirements, or if it is already protected, whether it will make a valuable long-term study site. In order to assess the importance of a site, taxonomic groups have made the study in similar habitats elsewhere in the region are surveyed, so the relative value of the site can be assessed. Stage 2, monitoring ecosystem change. Once a site has been identified, a monitoring program for the study site established, so changes in the ecosystems can be assessed. Monitoring population levels of keystone species in the ecosystems is also an important element of these monitoring programs. Stage 3, monitoring socio-economic change. Conservation requires the cooperation of adjacent communities and data on how these communities interact with the study sites. For example, of this type of study includes the surveys of household income, attitudes to the adjacent protected areas and levels of compliance with the protected areas rule. Stage 4, establishing and monitoring the effectiveness of conservation management programs. The final stage is when international funding is received to establish a best practice conservation management program. These surveys are also examine the effectiveness of existing conservation management programs. The National Koala Conservation and Management Strategy aims to conserve koalas by retaining viable populations in the wild throughout their natural habitat. The success of the strategy will hinge on the participation of the community, conservation groups, industry and developers, local government authorities and researchers working cooperatively with state and Australian government authorities using the attached implementation plan as a tool for coordinating action and monitoring progress. Limitations of management strategy evaluation. Management of natural resources is plagued by uncertainty and feedbacks between the dynamics of resources and users. Although MSc goes some way towards addressing these difficulties, it has been criticized for number 1, having a longer development time, that is increased cost also than traditional methods such as reference based off-take rules. Second, an upfront MSc can provide an overly rigid framework without room for decision makers to change management in an adaptive way. Third, poor data inputs, that is gaps in monitoring or extremely low estimates of uncertainty affects the performance of MSc, which needs to be recognized and explored within the MSc process. These criticisms point to the need for an iterative process of monitoring, learning and adaptation, which is entirely in keeping with the MSc approach if practitioners are prepared to engage with the issue being raised. To summarize this module, we can say that conservation management strategies is an important chapter of ecology, and it helps us to conserve the flora and fauna of the world. Thank you.